Hi, everyone. Hope you're having a good morning. My name is Rand. I've been a developer since I'm 10 years old. Built my first company when I was 14, ended up doing a PhD in artificial intelligence when I was 21. I was advising the French government on the AI strategy, and then I run the biggest AI company in France. Today, I want to talk to you about the reason why I believe that human-like artificial intelligence is never going to exist and what that means for the future of work. So can I ask you, who here has heard the term artificial intelligence? Yeah, I mean, I would assume, right? Who here can tell me what actually it means? Someone yesterday had a good definition, so I'm going to share that with you. Artificial intelligence is the ability to reproduce human behavior in a machine. That's it. Take what a human can do intelligently, put that in a machine, and you've got artificial intelligence. Within AI, you've got one type of way to achieve this, which is called machine learning. The idea of machine learning is that you're effectively teaching machines to reproduce the behavior by giving it examples. A little bit like those kids' book, you know, where you have pictures of animals and it's written the name of the animal, and then after seeing a few pictures of horses, your kids know how to recognize horses. It's exactly the same thing in machines. And machine learning is a very big deal because up until now, when you wanted to automate something, a human had to first understand what was going on, then sit down and program a machine to do that. So automation was limited to what humans were able to understand. With machine learning, all you need is data collected from what you're trying to automate, and the machine does everything else. You no longer need a human expert in the loop. And within machine learning, there is one type of algorithm that's called deep learning. So deep learning is a branch of machine learning, which is a branch of artificial intelligence. And you could consider all three to be interchangeable today, but that's going to change in the future. I don't believe the word artificial intelligence is actually going to be used in marketing in a few years. So how have we been using deep learning? Deep learning has been a huge revolution. You know, we see it happening for self-driving cars. We see it happening for medicine. So medicine is a very, very important use case for artificial intelligence because we have today AI that can diagnose radios, X-rays, or that can diagnose MRIs better than humans can. You've probably all heard about that. I think a lot of you probably have one at home, right? This is called Alexa. It's a voice assistant from Amazon. This is one of the fastest growing consumer product ever. Rumors are that 1 in 6 American uses that. This appeared 4 years ago. This was not possible before because deep learning was not enabling us to talk to machines as naturally speaking. Have you heard about this? Yeah? Do you know what this is? This is the world champion basically playing against Google's artificial intelligence at the game of Go. The game of Go was considered to be extremely complicated for an AI to beat because the number of different combinations meant that the only way for a machine to beat a human is to actually learn how to play the game. And so we thought this was still 10 years in the future. The way that they made this work was really interesting. So they took one artificial intelligence and they made it play against another one. So one was playing the white side, one was playing the black side. But the trick is that every time one of the AI played a move, the other one gave it feedback on that move. So AI one would play a move, the other one would say, oh, I think this was good or bad. And by mutually reinforcing each other, by playing millions and millions of games, eventually they learn how to play the game better than any human. At the time, when they played against the world champion won 1 out of 5 games. So this was amazing. But people felt a little bit reassured. You know, they were like, oh, 20% chance of surviving AI, that's still not bad, right? I mean, it's not what people tell us in movies. However, the same AI kept on learning. It kept on learning. It kept on training. Today, not a single human can beat that AI at a single game. But there's more. There is a new version of this AI that beats the AI that beats every human at every game. And so, you know, when I saw that, I was like, oh my God, this is just getting out of control. You know, this is getting out of our hands. But what you need to understand is that everything I just talked about, however impressive it is still something that is called narrow artificial intelligence. Effectively, those machines are able to do one thing, perhaps do it better than a human, but they're only doing this one specific thing. And so the AI that played the game of Go, that was a breakthrough, but it doesn't know how to do anything else than play the game of Go. And so now people are working on something that's called general artificial intelligence. This idea that a machine could solve any logical task, that it could reason, that it could transfer the learning it had from something to something else. And this is major, because if you can have this general form of intelligence and reasoning, then potentially machines could do anything that seems like intelligence. But this is still not what you see in movies. What you see in movies, this very human-like artificial intelligence, is not just reasoning and logic. It also includes the ability to emotionally connect with humans. And so artificial human intelligence, as we've been talking about, is really this combination of logical intelligence and emotional intelligence. It's IQ plus EQ. If you only take IQ into an equation, you don't end up having human intelligence. And so why is emotional intelligence important? I mean, I think everybody here probably thinks it's important, I'm hoping. But it's very important because it's a way that as humans, we can solve paradoxes. So a paradox is a mathematical problem for which there is no logical solution. This is a paradox. It's a trap for self-driving cars. It's very, very, very clever. So I don't know about the road regulations in the US, but in Europe, you're not allowed to cross a white line. And so to trap this car, what you do is you basically draw a dotted line circle on the floor, and inside of it, you draw a white solid line circle. From the outside, when it's dotted and then white, you're allowed to cross. So the car from the outside sees that, just drives through, right? However, once you're inside, it becomes solid, and then it's dotted on the outside. You're not allowed to cross that. The car is trapped. This car, with its IQ of like 15 trillion, that has learned on billions of hours of driving videos and sensors, that has 0 road accidents, still cannot figure out a basic trap, because there is no logical way to solve that trap. You as a human, if you're driving and you see that, what do? You just laugh, you're like, yeah, whatever, and then you keep going, right? Let's be honest. Why? Because at that precise moment, you didn't use logic, your IQ didn't help you. You use your emotional understanding of what a joke is, you use common sense, you use culture as a way to determine that it's okay to cheat and just, go on. So a machine, if it's not able to have emotional intelligence, will never be able to solve those logical traps, which means that as humans, we can use our EQ to find traps for machines that have very high IQ. So now you might be thinking, well, aren't machines building emotional intelligence as well? I mean, we see all those amazing robots. People develop feelings for those robots as well. That's true. However, what I believe is that you will never have true emotional intelligence in machines, because emotional intelligence first requires artificial consciousness. Can we first agree on what consciousness is and maybe perhaps determine if animals have it before we start building it into a machine? Then you also need to feel emotions. And this is very different than pretending to have emotions. It's very easy for me to learn that when someone is smiling, that person is probably happy, and it's very easy for me to smile back. But hey, I can be smiling, it doesn't mean I feel happy right now. There's a big difference between perception of emotion, between display of emotion and feeling emotions. And what we know for a few years is that humans who don't feel emotions are incapable of making decisions on a daily basis. They can do math, they can solve mathematical puzzles, so they have very high IQ potentially, but if you ask them, what do you like for lunch? Would you like, a fish, or would you like chicken? They cannot answer that because there is no algorithm to answer that question. And so given that as humans, most of our decisions are emotionally driven, let's be honest, right? We use the data to back it up, but we make emotional decisions mostly. A machine that doesn't have an emotional intelligence will never be seen as a human-like type of intelligence. But then some people argue, well, consciousness, emotion, these are just, consequences of the brain's connectivity or whatever. Sure, But your brain is not in void, right? It's not like in a box or something. Your brain is in a body, and that body has a very specific type of sensors. So the way that you perceive the world has a huge impact on the notion of what it means for a human to be intelligent. So if you want a machine to display the same level and a human-like type of intelligence, it needs to have ears, it needs to have touch, it needs to have taste, it basically needs to have the different senses, and it needs to have them like a human does. The eye has a resolution of about 10 photons. We're very far from being able to achieve that in a machine. So now, you have to reproduce artificial consciousness, artificial emotions, artificial senses. But on top of that, there is also collective intelligence. You know, you're not by yourself. You're not living in a cave alone, right? You're living with other people. And collective intelligence emanates from the fact that you're part of a human group and that group treats you as peers. It doesn't work if people consider you a machine. So an AI, to understand and gain collective intelligence, would need to be so human that humans wouldn't actually see it's an AI and treat it like a human. So now it's a little bit of like a catch-22 thing, right? Like, how do you make an AI that has collective intelligence if it needs to already be human to have collective intelligence? And finally, there's a very big issue of energy. The human brain consumes an average of 20 watts. An equivalent AI, so if you took as many neurons and you connected those neurons with transistors and basically wires, would require 10 million watts of energy to operate. One human brain, one equivalent AI brain that doesn't do more than a human brain, by the way, it just does exactly what a human brain does, 10 million watts. That's like a small power plant for one AI. So now you gotta fix the energy issue. I'm gonna be honest with you. If you solve any of those issues, you've already got a great business. But now if you're trying to solve all those issues together, so you're trying to recreate artificial consciousness, artificial emotions, artificial body effectively, artificial collective intelligence, and make it very efficient, you're basically recreating a human. And if you're gonna do that, you might as well just have a kid, right? Because that's what a kid is. A kid is someone that you teach stuff to, right? Why would you go around and trying to do that in a machine? It makes no sense. It just makes no sense. And it's not the first time that we've tried to explain intelligence with, you know, the theory of the time. Back a few thousand years ago, people tried to explain that intelligence was a humor, right? You remember bile, like blood, people would just draw blood of their body. People thought intelligence was also a fluid, and this is how it worked. Then at the time of Descartes, of those philosophers, people invented, you know, mechanical stuff. And everybody thought that you could build an automata, which is basically a robot that you activate with a crank, pretty much, and that would display intelligence. The best example of an intelligent automata we had at the time was something that was called the mechanical Turk. The mechanical Turk was a robot that could play chess. And so the inventor would go around Europe and play chess with people, and it would be pretty good at playing chess. And people were like, oh my God, like a robot can play chess. That's the end of the world. Like, we're done, we're doomed. What are humans gonna do? An entire school of thought developed around that called the mechanists, right? There was a really big deal at the time, really big deal. However, the way that the mechanical Turk actually worked is that underneath the robot, there was like a box. And in the box was a human. And the human was moving the pieces. So it's a human pretending to be a machine that was basically displaying intelligence. And the term today still exists in AI. We use the term mechanical Turk to refer to when a human does something that an AI is supposed to do, but the person on the other side doesn't know it's an AI or a human doing it. And so it's just something that we've always fantasized about, this idea of reproducing intelligence. Then we thought it was electricity, because it has to be electricity. After all, there is electrical nerves and there's all of these things in your brain, so why would it be any different? That didn't really work out. Then we thought it was communication theory, right? You're communicating information in your brain, and therefore this is how intelligence works. Some people even consider the telegraph as a good metaphor for intelligence at the time. And then, of course, computers. In the 50s, people started thinking that human intelligence in the brain was just input-output, right? You input stuff, you input data, and you output something intelligent. However, that is really not how it works. If you open someone's brain, You don't really see a CPU and a hard drive, and it doesn't really look like that at all. As a matter of fact, if you open someone's brain, you have no idea how it works pretty much. And then today, of course, it's artificial intelligence, machine learning. But these things, we're just going to keep doing it because we have that fantasy of reproducing human intelligence. And so what I'm trying to get to here is that, yes, you will have an AI that has an IQ of 5 billion. And yes, every logical task is potentially doable by a machine. But humans will have the monopoly of emotional intelligence. Humans alone will be able to do emotionally driven tasks. And so rather than think about machines replacing humans, we really have to start thinking about humans and machines working together. How can we leverage the horizontal emotional intelligence of humans with the powerful mechanical, logical intelligence of machines? And so rather than try to build an AI that replaces humans completely, why don't we start building an AI that actually works with a human in a very natural, very intuitive way? And there are a lot of people working on that. And this isn't science fiction. There are people today who are able to connect a few neurons of your brain to a machine. So brain-machine interfaces are becoming reality. Think about what that means when you're working on a daily basis. And this is actually something that I was working on when I was advising the French government. The initial brief was, what is going to be the impact of AI on jobs in France? What we initially thought is, well, everybody seems to say that there's going to be only 50% or so of unemployment. Let's figure this out. What we found is that using a very simple framework, where you take a job, you break it into specific tasks, and for each of those tasks, you determine, is it more of a logical task or is it more of an emotional task? Is it IQ or EQ that's involved? If it's mostly an EQ-driven job, that's completely safe. If it's mostly an IQ-driven job, then that's not very good. 10% of jobs in France are considered to be IQ jobs, like as in purely automatable by machines. So we're not talking 50% unemployment, we're talking 10%. Still a lot, it's 1 million people in France, that's huge. And frankly, 1 million people is a lot of issue to fix, but it's not what we've heard before. 40% are mostly EQ jobs in France, so meaning they're not really gonna change anyway. However, 50% are really sort of this in-between middle ground where, humans are still necessary, but machines can complement them very, very nicely, and together they can actually start doing things that are much more interesting. And so our recommendation was stop focusing and worrying about mass unemployment and rather start worrying about how to transition that 50% of the workforce into a world where machines and humans need to work together. And that fundamentally means that you need to continuously let them learn new skills as things are evolving. And so the recommendation we made was focus on getting companies to have their teams learn continuously as technology is adapting to their workplace. That is the key. The key to artificial intelligence and humans in the future is continuous adaptive learning. That's it. That's how you actually solve it. So the reason why I'm talking about all of this is because when people talk about AI, and many people talk about AI without actually building it, by the way, this is what a picture they paint of the future. A very dystopian, very scary, very oppressive future where we're pretty much like in the Matrix, we're robots ourselves, and we don't really have any free will or anything to do anymore, right? It's either this or people don't work anymore, basically. I don't think this is gonna happen. I think really, when you talk to people and you ask them, what do you really want? And when you look at where AI is going, what you realize is that the future will actually feel a lot more like this, right? It'll feel like a very stressless experience. It'll feel like something where people have purpose, where people actually enjoy the work they're doing, because we will have delegated to machines the things that we don't want to do as humans. And I think that if we can get to that point, where machines do machine work and humans do human work, not only can we potentially work less, we can also feel a lot happier. And this, for me, is the real promise of artificial intelligence, is this idea that you can make all of that technology, all of the stress disappear into the background so that humans can finally be happy. Thank you.